Welcome friends, in this one let's delve into some of the graphical underpinning behind the chain rule. We're going to use these two graphs. What are these two graphs and why are they arranged this way? Well, this graph right here, this is just following. We'll call it 1 over u. Therefore, this here is the u-axis, which means this here is also the u-axis. And notice they're kind of made to be parallel and aligned in values 0, 0, 1, 1, about 2, 2. So here u would be equal to x squared. The reason for that is this is a graph of the x squared function, but it's been turned 90 degrees so that the u-axis align. And then you can observe the following. Over here all the way on the bottom, then this vertical axis is actually the x-axis. What is this telling us? It's telling us that we have the following thus far. Y will be defined as 1 over u. So this right here is y. Take a look. Y is equal to 1 over u. And then we also now know that u is equal to x squared. And something specific happens. Using this sequence of pictures, we can make a graph like this. That otherwise is kind of hard to make. Let's see. So I'm going to begin at 1 here. Follow the arrow. This is my input of 1 on the x-axis. When I do that, it's going to hit the red curve. It's going to bounce off the red curve, and it's going to go all the way across this way, you see? So the output of plugging 1 into x squared becomes u, but that u is then fed into 1 over u. Which then lastly takes you back to this axis right here. This is visualizing the process of doing a function composition, of producing, in other words, an output. When it first goes into one function, x squared, and the output of x squared then goes into 1 over u, or in other words, 1 over x squared. So we need the u here for that reason, right? Because it connects the two graphs. The output of the first one becomes the input into the second one. Let's repeat this one more time at a different value. Take a look. Let me grab the green one here. This is a different value of x. And notice again, when it goes in, it's going to hit the red graph. That then is going to get bounced off, and it's going to hit the blue graph over here. So it's saying that's about, let's see, 1.2, 0.4, 0.6, 0.8. That's about 1.2 that's going in. It gets fed into x squared. It gets output here. That output then gets fed into 1 over u right here. And that gets bounced off the blue curve and output over here, see? About, roughly speaking. There's already the chain rule here if you think about it very carefully. You may want to pause the video and see whether you see some slope relationships. But let me kind of emphasize them now. So let me grab different objects here. Notice the following, that this right here, that's delta x. It's a change in the value of x. As x goes from 1 to 1.2, that's delta x. I should mark that, so delta x is right here. That same delta x, you can also essentially make a copy of it right here. Take a look. This here is also delta x. Right there, which means because this graph output here is u, then this part right here, that would represent a bit of the change in u. So in other words, it would be delta u right here. That's a bit of the change in this position. Now notice that delta u, so let's see, I need to emphasize that I'm going to use this bluish color here to emphasize it. Look carefully, right? So this here is delta u. That same delta u, look, make a copy of it and then translate it to here. You see this? Right there. That's also delta u then. So, delta u. It's copied up to there. Lastly, because this is y equals 1 over u, this part right here, this would be represented by delta y. Right there. That's delta y. So it's kind of emphasized that in red, for example. So this here is delta y. There we are. So now, you have delta x, that's the change in x. As that occurs, then you see that down below here, u changes this way. That's the change in u. That's like saying the following, in other words, in terms of a point that you are imagining. There's a point that begins here and then moves this way, and it stops in this position right there. Now, as that occurs on the red graph, then on the bluish graph up there, what happens is the following. You have begin with a point here and it moves down this way, see? Until it stops in that position. That means there's a delta u here, and as that occurs, then delta y is also generated this way. And somebody just gives you a bunch of random symbols, you really don't necessarily know how to assemble them into something meaningful. So what I mean is this. You could say, well, I could just say delta x plus delta y. I mean, does that mean something? Sure, I suppose it would mean whatever the change is in x, and you add to it the change in y. It means that, okay? What's another possible combination of these different symbols? You can also have du over delta x. as an example. That's probably more like what we want, just because that's the standard definition of slope. So take a look at it here. I'm going to take this down here. Look carefully. What this is saying is delta u is the change this way divided by delta x, which is the change this way. Notice that delta x is in the bottom and delta u is in the top. So in other words, if you take this lower graph and you turned it back to the left 90 degrees, it would look like the standard x squared graph, and delta u would be vertical, delta x would be horizontal. But the point is you would still have delta u over delta x, so it's a slope. Look at this combination of delta y and delta u. How can you combine them in some meaningful way? Again, because things are ultimately just created by people, you could say, well, I'm just going to take delta u and divide by delta y. Why not? So let's see. In other words, I could say for this one, I'm going to take delta u and divide by delta y. On the bottom, notice I have delta u over delta x. On the bottom, just as easily, I could have said, I'm going to take delta x and divide by delta u. So if I do that, I would have the following then. Imagine I take delta u, delta y from the previous picture up top, and I multiply not by delta u over delta x, but I multiply by delta x over delta u. I mean, the point is it's our world, so we are free to create whatever we want, as long as we make some sense of it. So if I look at this carefully, what is this telling us? It's just telling us that the delta u's would cancel, right? Look, you would have here delta x over delta y. What this says is the following. Every time I begin now on the upper picture, because the delta y is in the bottom, we usually imagine the quantity on the bottom is representing the independent variable, the one whose values you can control. If I change y by delta y, that causes a change delta u this way, which then gets propagated down to here, which then causes x to change by delta x. And that's why it says delta x over delta y. It makes sense. However, it's not standard in the following sense that most people imagine, for whatever reason, that delta x represents a change in x, and that x is the independent variable, it's the one whose values we can control. And then delta y is the dependent variable, is the one whose values are controlled. So usually we don't reason through it this way. Instead, we reason through it this way. We imagine that we begin here at point A. So that represents going from 1 and then causing a change of delta x. That causes B, right there, to slide down until it becomes C. Along the curve, roughly speaking, until it becomes C. As that occurs, then on this graph up here, you have A, B, C, so this would be D now. So D would kind of slide down until it becomes E. A, B, C, D, and then E. Once you understand it from that perspective, then the standard way to talk about the chain rule is to say the following. It would be delta y over delta u times delta u over delta x, which then lastly becomes delta y over delta x this way. That form of it is the standard one, and what it says is when x increases by delta x, then u equals x squared changes by delta u. As that occurs over here, y changes by delta y, and then when you multiply the slopes together, delta y over delta u times delta u over delta x, you end up with delta y over delta x. That just represents the effect that changing x by delta x has on the values of y. In other words, in that case, y changes by delta y. And that's why this graph clearly shows why you need that delta u as the intermediate step, so to speak. If it's been helpful and insightful, and if you've learned something, friends, please leave a like, please subscribe. I'll see you in another video.